thermodynamics, right? So let's understand what are the topics that we're going to study in the basic thermodynamics. So I'll just start this thermodynamics first, right? So this thermodynamics part has been divided into two groups basically. The first one, it is defined as your basic thermodynamics, and the second portion is defined as your applied thermodynamics, right? So let us see what are the topics that we are going to study in this basic thermodynamics portion. The first one that we will study, that is your basic. First topic is defined as your basic concept of thermodynamics, right? The second one we are going to study, that is your zeroth law of thermodynamics, right? And the third chapter we are going to study is your energy interaction. Now the fourth one that we'll study, that is your first law of thermodynamics. The next one is your first law applied to flow process, right? First law applied to flow process. Now, the next chapter that we'll study is your second law. Second law thermodynamics. The next chapter is your entropy. And eighth one we are going to study is your availability concept, right? Availability, that is available energy we have in that case. Then yes, the ninth one, which is you can say the in between, or you can say connection between the basic thermodynamics to applied thermodynamics. So ninth chapter that we are going to study is your properties of pure substance, right? So these are the topics that we need to understand in basic thermodynamics, right? Now, applied thermodynamics. So in applied thermodynamics, so we are mainly concerned about whatever we have studied in the basic thermodynamics. So its application part comes in this applied thermodynamics. So I just want to again segregate this applied thermodynamics in two parts, right? So based this segregation based, you can say based on working fluid, right? So based on working fluid, it has been segregated in two parts. The first one, it is defined as your vapor power cycle. So vapor power cycle, and second one is defined as your gaseous power cycle. The first one is defined as a vapor power cycle. The second one is defined as a gaseous power cycle. So I already said that it is to be segregated based on the working fluid. It means what? In vapor power cycle, the working fluid in any power cycle should be, you can say the steam, or you can say the water. So here we are more concerned about conversion of water into steam. Similarly, in gaseous power cycle, we are more concerned working fluid as an air. So here we are going to study air standard, air standard cycle, right? Now, vapor power cycle is defined as your Rankine power cycle. vapor power cycle is vapor power cycle is defined as, in vapor power cycle we'll study about the Rankine cycle. We will see what is Rankine cycle. Likewise, in air standard cycle, we'll first study the Carnot cycle. Carnot cycle, in second point of that, we'll study on Ericsson and Stirling cycle, basically. Then we'll study Otto and diesel cycle, and lastly we'll study your gas turbine. So gas turbine means your Brayton cycle, right? So these are the cycles we are going to study. Along with that, we'll cover some of the portions of the compression and all these things, which is again comes under the applied thermodynamics part, right? So I believe, is it clear to everyone that what are the, you can say, the content of our theory class as well as our numerical class, right? So the topic that we will start, the first topic, that is defined as your basic concept, basic concept of thermodynamics. Right. So in this topic, we are more concerned, or we need to understand the terms which is applicable in thermodynamics. So let's first understand कि कौन कौन से ऐसे टर्म्स हैं जो हमारे सामने यूज टू होते जाएंगे और उसका एक्चुअल विद रिस्पेक्ट टू थर्मोडायनेमिक्स क्या सिग्निफिकेंस होता है, राइट? With that, let us first understand what is this thermodynamics is, right? So when I'm talking about the thermodynamics, so I'll just write this word thermodynamics, thermodynamics, right? So you can see that itself, the name appear has the many meanings. I'll just segregate that in two parts, that is thermo and dynamics, right? So what is thermo? Thermo means here it is defined as heat, and dynamics. So with respect to in motion, the dynamics here we are concerned about the work, right? So the main aim of thermodynamics study is to convert disorganized form of energy, right? So here we are considered heat as a disorganized form of energy, disorganized form of energy, right? Which is defined as a heat. Likewise, into organized form. So we are concerned about the conversion of heat into work. So here, heat we have defined as a disorganized form of energy, and we are converting heat into work. So work is considered as an organized form of energy. Organized form of energy, right? So that is the concept of thermodynamics is, it is the science of energy transfer and its effect on the properties of system. So with respect to definition, we just write it is the, you can say, it is the science, it is the science of energy transfer. It is the science of energy transfer and its effect, and its effect on properties, on properties of system, right? So आपने यहाँ पे क्या देखा कि जो फर्स्ट टर्म जो थर्मोडायनेमिक्स में वो निकल के आपके सामने आ रहा है, दैट इज अ सिस्टम। इसका मतलब वी नीड टू अंडरस्टैंड फर्स्ट कि भैया कौन से सिस्टम की हम बात कर रहे हैं, राइट। तो अब हमको ये समझना इम्पोर्टेंट है कि हमारे लिए सिस्टम क्या है और किस सिस्टम के रिस्पेक्ट में हम एनर्जी ट्रांसफर को डिफाइन करेंगे, राइट। तो अब हमको यहाँ पे जो सबसे पहला टर्म आया जिसको हमको समझना है, दैट इज द फर्स्ट थिंग, with respect to thermodynamics we need to understand what is system, right। so now system है क्या? system अगर हम define करें, it is the region in space on which, if I'm going to write its definition, we can write it is the region in space, it is the region in space on which, it is the region on which the study, on which the study is focused, right, or you can say concentrated. So whenever a system come in front of you, you need to define a specific region in space, ठीक है। जैसे let's for an example, अब if I say कि suppose this is your right. So we were talking about the system, right? So that definition I've already written with respect to the system, right? I'm just giving you an example about the system, right? So you can see that suppose this is a one container and you are going to fire it with some burger, right? Now this is the fluid is to be there inside this container. तो क्या होगा? You can see that कि जैसे ही ये फायर हो रहा होगा तो energy, that heat is going to transfer from one part of the system to another part of the system, right? Now the important point is कि at this point हम किसको अब यहाँ पे system बोले और किसको हम इस चीजों को define करें। So as per the definition we have said that system is a region in space on which the study is focused. तो अब हम किसकी स्टडी कर रहे हैं? हम यहाँ पे बर्नर की स्टडी कर रहे हैं या हम यहाँ पे कंटेनर की स्टडी कर रहे हैं? That we need to identify first. So it means what? Whenever I'm talking about a system, the system is a space in a region in space जहाँ पे हमको concentrate करना है और हम उसको concentrate तभी कर सकते हैं जब हम उसकी एक boundary define कर सकें, right? So the system is always associated with boundary. तो यहाँ पे जब आप इस सिस्टम्स की बात करोगे तो आप यहाँ पे उसको बाउंड्री के साथ उसको सेग्रीगेट या सेपरेट करोगे। तो इफ आई से दैट टू इज वन सिस्टम, so this system is defined as a container, right? So I say that this is a one container which is a system, right? अब ये कंटेनर सिस्टम में हो क्या रहा? इस कंटेनर सिस्टम में यू कैन सी दैट द हीट इज ट्रांसफरिंग फ्रॉम वन टू टू। तो here we can write one, here we can write two. So heat, the symbol of heat is defined as Q. So we can say that the Q is transferring from 1 to 2, right? So anything, now we have defined 2 as a system. So anything outside the system is defined as surrounding. So 1 here is defined as what? Surroundings, right? So up, either you can focus on surrounding or you can focus on system. If I say we are going to focus on the system, तो हमें ये समझना है कि at इस particular point पे initially this is having 10 degree centigrade temperature. जैसे ही इसमें heat add हुई, after time t this temperature becomes 100 degree centigrade. तो इसका मतलब क्या है? आपने 90 डिग्री सेंटीग्रेड टेम्परेचर इसका इंक्रीज किया है विद द हेल्प ऑफ एडिंग हीट, तो हीट को हम ऐड ऐसे कर सकते हैं mc डेल्टा t। दिस फॉर्मूला विल कम सी इन द लेटर साइड, बट इसका मतलब क्या है कि जितना अमाउंट ऑफ टेम्परेचर इंक्रीज करेगा विद रिस्पेक्ट टू दैट उसका आपका अमाउंट ऑफ हीट ऐड हो जाएगा, राइट। नाउ अब हमको ये फोकस करना है कि सिस्टम 2 में हीट ऐड हो रही है, सिस्टम 2 का टेम्परेचर इंक्रीज हो रहा है। वी आर नॉट मच कंसर्न कि ये किस बर्नर से निकल के आ रहा है या कहाँ से हीट इसमें ऐड हो रही है। इट इज ऑल्सो पॉसिबल कि सन से आपको यहाँ पे हीट ऐड हो रही है, हीट इसमें ऐड कर रहा हो, यहाँ पे चीजें इंक्रीज कर रहा है। आपका ऑब्जेक्टिव क्या था? फर्स्ट यू नीड टू सी अंडरस्टैंड कि भाई दिस इज योर सिस्टम and this system's temperature is going to increase from 10 degree to 100 degree centigrade, right? So anything which we are going to focus or concentrate it is defined as a system. Now the second thing is, like we have already defined system, similarly we are going to define surrounding, right? Okay, surrounding is what? Anything. Surrounding means what? External anything external to the system. Anything external to the system is known as surrounding, right? Okay, how we are going to differentiate system and surrounding? Only with the help of boundary. इसका मतलब the role of boundary is very much important, right? So अब ये बाउंड्री है क्या? The separation between system and surrounding is known as boundary. The important point to note in case of boundary is a boundary. It can be real. It can be real. Real का मतलब क्या हुआ? अब आप इस examples को अगर आप यहाँ पे consider करो, you can say that this container, the walls of this container you have defined, आप उसको देख सकते हो. It has a physical shape, size, textures, colors, everything. It is to be real. It means what? Here in this case, you can say that the boundary is real. It is visible to you also. Likewise, it can also, it can be imaginary also. It can मतलब आपको बाउंड्री नजर नहीं आएगी, आपको उसको डिफाइन करना पड़ेगा, राइट? तो डिफाइन आप कैसे कर सकते हो? सिंपल वे में है कि आपने एक कंटेनर डिफाइन किया, कंटेनर, और आपने बोला कि भाई ये आपको इसमें से हीट प्रोवाइड कर रहा है। तो आपने क्या डिफाइन किया? इसके अंदर क्या रखा हुआ है? इसके अंदर रखा हुआ है आपका वाटर, ठीक है? जस्ट टेल मी वन थिंग, व्हेन यू आर गोइंग टू इंटरैक्ट दिस, अब ये जो वाटर है इसकी आपकी एक बाउंड्री डिफाइंड होगी, ठीक है? बट आप इसके टॉप पोर्शंस को देखो, ये कंप्लीटली ओपन है, तो इसका बाउंड्री है क्या? आपको नहीं पता इसका बाउंड्री। इट कैन बी दिस ऑल्सो और इट कैन बी दिस ऑल्सो। तो आपको एक पर्टिकुलर वैल्यूज को डिफाइन करना पड़ेगा। तो आपने क्या बोला कि सपोज इन फ्रॉम योर इमेजिनेशन दिस शुड बी योर बाउंड्री, ठीक है? तो अब ये क्या होगा? जैसे ही इसमें अमाउंट ऑफ हीट ऐड होगा तो ये बॉईल करेगा तो वेपोराइज होगा। तो वेपोराइज होने के बाद हो सकता है कि ये कुछ अमाउंट ऑफ वाटर इसमें से डिक्रीज कर जाए। तो ये गया कहाँ? ये सिस्टम से सराउंडिंग में गया ना। तो यू नीड टू अंडरस्टैंड कि भाई हमारे पास इनिशियली 10 kg वाटर था, आफ्टर सम टाइम हमारे पास 9 kg वाटर है, तो जो 1 kg अमाउंट ऑफ वाटर है ये सराउंडिंग में चला गया है। तो इसका मतलब कि क्रॉस तो तब ही करेगा ना जब आपका सिस्टम और सराउंडिंग के बीच में एक बाउंड्री हो। क्रॉस करने का मतलब है कि बाउंड्री को क्रॉस करना। So it means what? Your boundary can be real, your boundary can be imaginary. Similarly, the next important point with respect to boundary is it can be rigid, right? Or it can be flexible. अब rigid और flexible का मतलब क्या हुआ? सपोज आपका एक यहाँ पे एक पिस्टन लगा हुआ, ठीक है? अब आपने वाटर को यहाँ पे ऐड किया, तो जो वाटर में हीट ऐड हुआ तो उसका प्रेशर बढ़ेगा। तो प्रेशर क्या करेगा? इस पिस्टन को शिफ्ट करेगा। तो नाउ योर बाउंड्री इज शिफ्टेड टू दिस पर्टिकुलर। So you can see that initially you have this much amount of volume. After this much, after adding pressure, your volume becomes V2. So your वॉल्यूम के रिस्पेक्ट में बढ़ने का मतलब क्या है कि आपकी बाउंड्री भी जो है वो चेंज हुई. जब बाउंड्री चेंज हो रही है तो इसका मतलब क्या है कि इट कैन बी रिजिड फ्लेक्सिबल आल्सो, राइट. अब आपने क्या किया कि इसको सिर्फ यहाँ पे एक स्टॉपर लगा के रखा हुआ है. जैसे ही यहाँ पे स्टॉपर्स की आपने बात किया तो होगा क्या कि नाउ दिस इज फिक्स्ड, राइट. अब आप इसमें हीट ऐड कर रहे हो, यू आर गोइंग टू एडिंग हीट इन दिस पर्टिकुलर केस. बट हो क्या रहा है कि इसमें इसका टेम्परेचर इंक्रीज हो रहा होगा, बट दिस बाउंड्री कैन नॉट बी शिफ्ट, राइट. So it means what? This boundary can be real, imaginary, rigid as well as flexible. Okay. The next point that we are going to study is universe, right? So here we'll see what this universe means. जब भी हम यूनिवर्स आगे बात करेंगे आपको एक ही चीज समझना है, यूनिवर्स इज बेसिकली अ कॉम्बिनेशन ऑफ सिस्टम प्लस सराउंडिंग, राइट. System and surrounding. So universe is also one of the system, like we have already defined system, right. So similarly universe is also one of the system which comprises of system plus surrounding, right. So if I'm going to draw, suppose this is the boundary of the universe, right. In this boundary of the universe you will see that there is a sub boundary, and in this sub boundary the inside portion is defined as a system and the outside of this boundary is defined as surrounding, right. So that thing is very important, and one thing is always remember, like in universe, basically in universe energy remains energy remains constant, right. So that is the one important thing which you always remember with respect to universe. Okay. Now let us see. Now let's understand what are the types of system. Initially we have studied what is system. Now we are concerned about the types of system. So let's see. Where I'm going to understand what is the type of system. Okay. In this particular topic, I'll just write there are three types of a system. First one is your closed system. Second one is your open system. And third one is your isolated system, right? So let's draw in this one. Okay. Now, the next heading that we are concerned is your mass transfer. Then we have to define is your energy transfer, right? And the last one is that we'll see some of the example based on that, right? Okay. So when I say the type of system, right, the first system that we are concerned is about to know is your closed system. So what is closed system? In closed system, always remember one thing. In closed system, there is no transfer of mass. जब भी हम ट्रांसफर की बात करते हैं, always remember transfer means what? It is always, if this is your system, this is your surrounding. So whenever term transfer comes, so it should cross boundary. So this is basically, this is your boundary, right? So whenever this transfer comes, you always remember either this transfer from system to surrounding or surrounding मतलब from surrounding to system or system to surrounding, right? So it is a vice versa between system and surrounding. So in closed system, if I say, there is no mass transfer, it means what? कि अगर surround system के पास कोई mass है, तो it should not cross the boundary. किसमें? वो system में. It should only cross the energy transfer. सिर्फ और सिर्फ energy transfer ही define होता है, right? Just for one example. एक simple सा example मैं आपको लेता हूँ. Just tell me one thing. आपका एक container है जिसमें आपने water रखा हुआ. Suppose this is your water, right? This is your water. अब इसको आप क्या कर रहे हो? इसको burning अपने burners पे रखा और ये burn हो रहा. अब just tell me one thing. You just close this one. आपने क्या किया? एक lid रखा है और उसको यहाँ से cover कर दिया. Tell me one thing. क्या होगा? ये क्या करेगा? इसमें heat add करेगा burner. Yes. So heat is also one of the form of energy. I am telling this is Q amount is adding inside this container. What will happen? ये burn करेगा, ये boiling करना start करेगा, ये boil करेगा, इसमें vaporizations होगा. But जो vapors होंगे, it should come on the top of this one, right? But it should not cross the system. For us, this is the system, and this one is the surrounding. तो अभी क्या हो रहा है कि this is not crossing anything. System से surrounding में mass नहीं transfer हो रहा है, but yes, system से surrounding से system में heat add हो रही है, right? So this is a case of closed system. In closed system, you always remember closed system is also known as control mass system, right? So in closed system, there is no mass transfer, only energy transfer take place. So you can write with respect to that, you can write an example. You can write a piston cylinder arrangement. Okay? Piston cylinder arrangement, but the condition is it should be without wall, right? It should be without wall. Okay. I believe you have understood what is closed system. Now I'm going to explain you what is the open system, right? So it is you can see that when I say in a closed system no mass transfer, similarly in open system mass transfer as well energy transfer both can be take place. तो आप क्या कर सकते हो? सेम एग्जांपल्स में से ये जो आपने लिड दिखाया था इसको आप हटा दो, सिंपल, और इसको ओपन रहने दो, ठीक है? तो अभी क्या होगा कि यहाँ पे 10 kg का जो वाटर था वो हो सकता है 9 kg ऑफ वाटर हो जाए. 1 kg ऑफ वाटर इज इवेपोरेटेड टू द सराउंडिंग. सो दिस इज वन ऑफ द एग्जांपल ऑफ दिस वन. सो ओपन सिस्टम के एग्जांपल्स क्या हो सकते हैं? सिमिलरली जैसे हमने बोला कंप्रेशर, टर्बाइंस. सो दीज आर द एग्जांपल्स ऑफ ओपन सिस्टम, राइट? Now, the important one, that is your isolated system. Whenever I'm talking about the isolated system, always remember that isolated systems are those systems in which there is no mass transfer, there is no energy transfer. Always remember in isolated system, there is no mass transfer and there is no energy transfer. So the first example, you can say that all isolated systems can be considered under universe, right? अगर इसको आप आइसोलेटेड सिस्टम बोल सकते हो यूनिवर्स को, तो हो क्या रहा है? आपको पता है क्या कि जो भी चीजें हो रही है वो सिस्टम के अंदर ही हो रही है. इट शुड नॉट क्रॉसिंग आइदर इन टर्म्स ऑफ एनर्जी और इन टर्म्स ऑफ मास. द सेकेंड एग्जाम्पल दैट आई एम गोइंग टू टेक इज योर थर्मोफ्लास्क. जस्ट टेल मी वन थिंग. आपका एक बॉटल है थर्मोफ्लास्क का और आपने उसमें वाटर पोर किया. वाटर रखा है और आप चाहते हो, इनफैक्ट कॉफी रखा है सपोज 100 डिग्री सेंटीग्रेड पे कॉफी, तो आप क्या ऑब्जेक्टिव है कि थर्मोफ्लास्क में आप कहीं पे घूमने जा रहे हो तो भाई 100 डिग्री कॉफी है, आपको आफ्टर आफ्टर 1 आवर्स द टेम्परेचर शुड रिमेन ऑफ 100 डिग्री सेंटीग्रेड, ठीक है, सो दैट कि आप वो वही 100 डिग्री सेंटीग्रेड के जो कॉफी का जो टेस्ट है वो आपको मिलेगा, राइट। सिमिलरली अब ऐसा तो होगा नहीं ना कि आपका अगर इसमें मास ट्रांसफर, सपोज देयर इज अ लीक इन थर्मोफ्लास्क, तो क्या होगा आफ्टर सम टाइम द क्वांटिटी दैट इट इज ऑफ सपोज फॉर 2 लीटर है, तो ये चेंज होके जो है 1.5 लीटर हो जाएगा। आपके अजम्पशन में 2 लीटर में 10 लोग कॉफी पीते, बट अभी क्या हुआ, इट शुड बी मतलब आपके 10 लोग में से 8 लोग पी पाएंगे, भी 2 लोग नहीं पी पाएंगे कॉफी। So this should not be happen in a case of basically thermoflask. So your purpose is like it should be remain the quantity as well as the temperature remain same after you can say the change of time also, right? So these are the type of system which we need to understand. Yeah. So let's see the next topic that we are going to understand is the concept is microscopic microscopic and macroscopic approach of thermodynamics. Approach of thermodynamics, right? So what is microscopic? Let's see first, right? When I'm talking about microscopic, what does it mean? Uh, I'll explain this with the help of one example, right? In this example, let us see this case. Suppose there is a one, you can say a system, and in this system, there is small number of molecules of air is there, right? The number of molecules is less. अब इन चीजों को हम समझने की कोशिश, if we want to know or if we want to calculate what is the pressure of the system, if we want to calculate the pressure of the system, so we have two methods, right? If we want to find out the pressure of the system, then we have two methods. The first method is what? Very simple one. You just put a pressure gauge, right? This is a pressure gauge. What pressure gauge gives you information? जैसे ही आपने यहाँ पे pressure gauge लगाया, so it gives you an average reading, right? कि जो भी molecules होंगे उसका contribution, एक average values क्या है उसके basis पे आप उसको calculate कर सकते हैं, right? So it gives you an average. The second thing is like, suppose आप every molecules, every individual molecules कितना contribution pressure पे exert कर रहा है. So अगर आप pressure को समझते हो, what is pressure? Pressure is basically force per unit area, right? So each molecules in as per the kinetic energy theory of molecules, when molecules always move in a random direction, right? So each molecules when it collide, it exert pressure. Similarly, this molecules when hit to the walls of the container, it also generate pressures on that particular walls, right? So we can do one thing कि we are more concerned कि हम हर एक individual molecule का pressure consider करें, right? और उसको sum करें. So we can also say that the summation of all molecules pressure, right? So ये क्या है? That approach is defined as कि आप individual level पे जब बात कर रहे हो, आप हर एक molecules को समझ रहे हो, उसके basis पे चीजें define कर रहे हो. Yes. So microscopic terms defines कि हम every individual molecules if taken into consideration, then this type of approach is defined as microscopic approach. right? Similarly, if we are concerned only the average behavior of molecules, कि भैया हमको ये पता है कि नंबर ऑफ मॉलिक्यूल्स कितने, हमको उससे कोई फर्क नहीं पड़ता है, यहाँ पे जितने भी मॉलिक्यूल्स हैं वो टोटल अमाउंट ऑफ समेशन, एक एवरेज, एक टेंटेटिवली वैल्यूज हमने डिफाइन कर लिया और कैन फाइंड आउट विद द हेल्प ऑफ प्रेशर गेज, राइट? नाउ अब यहाँ पे जो इम्पोर्टेंट पॉइंट समझने की वो ये है, now see, if you have a less number of molecules, right, say very less number of molecules, it is practically easy to calculate this method like microscopic approach, because you can easily identify, easily monitor the individual molecules behavior. But जैसे ही आपने यहाँ पे देखा कि number of molecules is large, so it's been practically very difficult to identify each molecule's behavior. और हम वहाँ पे क्या समझने की कोशिश करेंगे कि भैया we are not concerned कि individual क्या कर रहा है, we are concerned at moment एक particular wall का, एक particular container का क्या pressure है. So that approach is defined as macroscopic approach of thermodynamics, right? In a very general sense of you can say example, suppose in a class, अगर हम छोटी सी क्लास को समझने की कोशिश करें तो we can say that in a class अगर around 10 students हैं तो it is practically very easy for any faculty to identify the name or even identify the progress or monitor their growth rate, right? And they ask everyone's name in the class. But in a pack of 400 or 300 students, this faculty is being very difficult to understand कि भैया हर एक इंडिविजुअल लेवल ऑफ बच्चा क्या उसका मॉनिटर है या क्या उसका नाम है. तो they have defined in a class of 10%, they know the names of individual persons, right? In a class of 400 students, what they say that okay, this is the 400 students of gate mechanical. So you understand the difference. Now gate mechanical contains 400 students. तो ये 400 students की growth को monitor करने के लिए वो examination conduct करेगा, उस level पे देखेगा. But 10 students को वो individually चीजें देख सकता है कि every students कितना marks score कर रहा है with their names, with their behaviors. They have to identify it in that particular match, right? तो अगर हमने बोला कि 400 students, that approach is defined as your macroscope. If I say an individual behavior, that approach is defined as microscopic level, right? So I'm going to write the definition of that one, and you will also understand in this particular. So I'm going to write the definition of this microscopic. It is better that you just write it in this approach. The behavior of, in this approach, the behavior of individual molecules is taken into consideration. And this approach is also known as statistical thermodynamics. Statistical thermodynamics, right? Now, the important point in this particular is it is always useful. This approach is always, you can say, it is always useful at higher altitudes, right? Why higher altitudes? Because at higher altitudes the density is low. and when density is low, correspondingly number of molecules is also low. In higher altitudes, density low, correspondingly number of molecules also less, right? Okay. Now let's see what is with respect to the definition part. Let's understand what is macroscopic approach of thermodynamics, right? So I already explained you about the concept. Just write down the definition. In this, please write it down. In this, the behavior the behavior of individual the behavior of individual molecules is not taken into consideration. Not taken into consideration, right? But the average behavior of molecules is taken into consideration. Taken into is taken into consideration, right? This approach is also known as classical thermodynamics. Classical thermodynamics, right? Now, let us see what is thermodynamics equilibrium, right? When we say that it is thermodynamic equilibrium, let's understand when we say that it is thermodynamics equilibrium, right? So, so when what is thermodynamic equilibrium? A system is said to be. Always remember, we are always focusing a term a system, right? तो इसका मतलब क्या हुआ कि जब हम किसी को भी हम नहीं बोल सकते कि थर्मोडायनामिक इक्विलिब्रियम है, हम सिर्फ उसी को डिफाइन करेंगे जो हम जिसकी हमको स्टडी कर रहे हैं. इसका मतलब वी आर ऑलवेज कंसर्न्ड अबाउट द सिस्टम. द सिस्टम इज सेट to be thermodynamics, you can say thermodynamics equilibrium, right? A system is said to be thermodynamics equilibrium if it satisfies, right, the following three conditions. वो कौन सी conditions है? पहला, it should be thermal equilibrium. Whenever I am talking about a thermal equilibrium, okay, so a system is said to be thermodynamic equilibrium if it satisfies a thermal equilibrium, right? So whenever I'm talking about a thermal equilibrium, it means what? I'm more concerned about equality. You can say equality of temperature, right? So those जिन्होंने भी ये बोला कि it is a heat, it is a temperature, it is an energy, so everything comes under this part, right? Now the second important point is mechanical equilibrium. Mechanical equilibrium, right? So mechanical equilibrium means what? Again, equality of forces, or you can say the pressure. Now the third one, which is your chemical equilibrium. chemical equilibrium, right? So chemical equilibrium means what? Chemical equality of chemical potential. So these are the terms which is defined. Now important thing is, whenever I say thermodynamic equilibrium, it means what? It should satisfy all the three criteria. If any one of the criteria is not satisfying in any of the cases, we cannot say that it is thermodynamic equilibrium conditions. Okay. Now let's see what is pure substance, or which substance is come under a pure substance. Let's see. What is pure substance, right? So remember, a pure substance, you can say a substance is said to be a pure substance. A substance is said to be a pure substance if it homogeneous. The first point is if it homogeneous in chemical composition. Homogeneous in chemical composition. And the second one is it is also homogeneous. It is also homogeneous in chemical aggregation, right? So whenever I'm talking about this chemical aggregation, it means what? We are talking about the bonding between the molecules, right? So pure substance satisfy the two criteria. It should be homogeneous in chemical composition, it should be homogeneous in chemical aggregation. जब तक ये दोनों criteria simultaneously satisfy नहीं करेंगे, we cannot say any substance to be pure substance. Let's take in one example. Okay. Now see, in this condition, you can see that in this container, there is a true substance which is defined as H2O. It's the hydrogen oxygen ratio is 2:1, and it is in the form of steam, right? Now again we are defined H2O, which is 2:1 ratio, but it is in the form of a liquid. We say it as a water, right? Now take it another example, right? अब इन दोनों को अगर हम समझने की कोशिश करें, we'll see in that particular manner. In this container, there is a oxygen H2 plus 2, but here in this case, chemical bonding is you can say the composition is same, right? H2O, but bonding is different because H2 plus O it is to be defined. In the bottom portion, we define again it is as a water. You can say that H2O, that is 2:1, right? Now let's say the third case. So once we draw all the cases, then we'll compare each one to each other. Now here in this case, H2 plus O2, right? Now you can see that the composition here is 2:2, yani that means 1:1, right? Now in the bottom one, again we are considering water, which is a composition of H2O, that is 2:1. Now you can see that. Now I'm going to compare one to other. This is your one example, this is your second example, and this one is your third example. Now tell me one thing. If I say it is a pure substance, right? So if it is a pure substance, then it should satisfy these two criteria simultaneously. Now the first criteria is chemical composition. Here in this case, you can see that the chemical composition here in this case is 1:1, and here is 1:2, right? The first criteria is not meeting, right? Similarly, the second one, it is a chemical bonding. Now this is H2 plus O2, right? And here the bonding is different from it. So second criteria is not meeting that. So it means what? If you put it these two substances in one container, we cannot say that this is a pure substance. Similarly, just compare it with the first one. First one में आपका first criteria, that is your chemical composition, that is 2:1, 2:1 meeting one. So yes, it's satisfied. Second criteria, chemical composition, yes, H2O of steam and H2O of water are both the same, that we can say that this is a, so the first one we can say that it is a pure substance. It does not matter whether it exists in a solid phase or a liquid phase or a vapor phase, but it meeting both the criteria. And based on this criteria, we can say that these substances are in a pure substance. So the first one is a pure substance. Now let's talk about the second one. In the second case, you can see that the chemical composition is same, but in the second case, again the bonding is completely different. So you can say that the second criteria is not meeting in the second case, like chemical bonding is different. So the second and third are not a case of pure substance. Though it may be a some substance, but it cannot be considered as a pure substance. In the coming chapters, we'll also define the properties of the pure substance and how it is going to be work in that particular manner. The next uh, property that we are going to define is your properties of a system. Properties of a system. We can say that what is the properties of a system? All measurable characteristics are properties. Likewise, we can say that suppose this is a system, right? So with respect to that system, what an individual is more concerned, like if I'm talking about the properties, to tell me what is the property of a system, this if this is a system, then we want to know that okay, in this system what should be the temperature, what should be the pressure, what should be the volume, likewise what should be its density, its mass, right? Or you can say the thermal conductivity. So these are the properties which are measurable in terms. So if I ask you what is the property of a system, your answer should be properties. Let me first understand that property is a measurable characteristic. So what properties you are asking? If I say what should be the temperature, you let me know this temperature of the system is of 100 degree, pressure is this one, volume is this one. So this is the properties, right? So with respect to that definition, we can say that all measurable characteristics. You can say that all measurable characteristics are properties. Right? Now, all measurable characteristics are properties. Like examples like pressure, temperature, pressure, temperature, volume, density, etc. Right? So these are the properties of a system. Now, this properties is been divided in two types. So the two types, the properties we can say is been segregated. Properties is been segregated in two types. So you can say the properties are of two types, right? So what the first one is defined as your intensive property. Intensive is also defined as intrinsic property. The second properties is defined as your extensive, which is also defined as extrinsic, right? So what is intensive and what is extensive? So we can say that in intensive properties, all properties are independent of size and mass, right? So when the properties are independent, when the properties are independent of size or mass, it is defined as intensive property. So what should be the extensive properties? The extensive properties are those properties which are depends on mass, right? So I'll tell you what are the examples of these intensive properties. Like we have defined here in this case, pressure, temperature, density, viscosity, thermal conductivity, etc. Right? So these are the intensive properties. So what are the examples of the extensive property? So you can see that extensive properties like it is defined as a volume. An important one is all forms of all forms of energy, etc. Right? So in this slide, we have defined the properties of a system. Any measurable characteristics are defined as the properties. Again, properties are of two types: intensive properties and extensive properties. Intensive properties are independent of mass, size, and extensive properties are mass dependent. Okay. Based on this one, there is an important notes in this property. Please write it down. Right? The ratio of two extensive properties. This is a worth remembering point. Ratio of two extensive properties is an intensive properties. Is an intensive property, right? So here in this case, the examples, you can see that density is one of the classic example of this one. You can see that density is a ratio of mass upon volume. Mass is also an extensive property, volume is also an extensive property, but the ratio of these two properties defined as an intensive property. Simple. You can see that 1 kg of water density is equals to 100 kg of water density, right? Here in this case, you can see that the quantity is different, but both density is same, right? So the density is an examples of intensive case. Similarly, you can see that the specific properties, all specific properties, you can see specific properties are intensive properties. Example like a specific volume, right? So a specific volume is what? वॉल्यूम डिवाइडेड बाय मास. So whenever I'm talking about the specific, ये हमेशा याद रखना. This specific term is very important. So whenever I'm talking about specific, तो अगर volume specific volume है तो volume divided by its mass, right? Similarly, whenever I'm talking about specific internal energy, so its symbol should be written like this. So that is internal energy divided by mass, right? Internal energy is again a extensive properties, and when it is divided by mass, it should becomes a intensive property. Similarly, specific enthalpy, right? It is defined as this one. Similarly, specific entropy, which is again defined as S by N, right? So these are the examples of intensive properties, which is again a ratio of two extensive properties, right? Now, we need to understand some of the important points with respect to properties, right? So these are a very important points. You can say the important point with respect to property. The first one, properties. All properties, remember, all properties are point function. Properties are point function. So with respect to differential, we can say that the properties are a point function. It means it is also defined as exact differential. Always remember. Right? Second, properties are independent of past histories. Properties are independent. Properties are independent of past history, right? Past history means a path it follows. Path it follows. इसका मतलब क्या है? I just give you that. Suppose when I'm talking about the properties, properties are independent of past history or path it follows का मतलब क्या है? Before to understand this one, let us define a process. ठीक है? और उसके बाद state of a system. तो हमको ज़्यादा समझ में आएगा कि what is the past history और path it follows का मतलब क्या होता है, right? So let's understand this is a process. Okay. A change of state is known as a process. We can say that a change of state is known as a process. So you can see that suppose this is a coordinate system, or you can say a pressure volume coordinate system. आपने एक सिस्टम का एक ग्राफ ड्रॉ करने की कोशिश करते हो जिसमें आपने बोला कि दिस सिस्टम हैविंग वन प्रेशर जिसका नाम है P1, दिस सिस्टम हैविंग वन वॉल्यूम जिसका नाम है V1, राइट? So this is a measurable characteristic, this one is also a measurable characteristic. Based on this value you have defined a point here, right? Now अब आपने क्या किया होगा, आपने इसमें हीट ऐड किया और सिस्टम को डिफाइन किया. Whenever you are adding a heat, तो हो सकता है कि ये आपका मूवेबल होगा, पिस्टन सिलेंडर अरेंजमेंट, दिस इज acquire a new dimension. So based on this, the new dimension should be P2 and V2. Okay. So this is the coordinates of P1, V1, and suppose this should be a coordinates of P2, V2, right? So this one is a P1, V1 coordinate initial condition. This one is a P2, V2 coordinate, right? Now, when I say a process, तो प्रोसेस क्या हुआ, अ चेंज ऑफ स्टेट हुआ. इसका मतलब सबसे पहले आपने क्या है, स्टेट को डिफाइन किया. तो P1 V1 इज वन ऑफ द पॉइंट व्हिच इज डिफाइंड एज अ स्टेट, एंड ये पॉइंट आप तभी डिफाइन कर सकते हो व्हेन द सिस्टम इज इन इक्विलिब्रियम कंडीशन, राइट? So when the system is in equilibrium, you define a state. Likewise, you have defined another state, and the change of state is defined as a process. So this should be one line which is defined as a process, right? So this is basically a process, or you can say a path, right? Up in between two points, ये आप तभी ट्रेस कर सकते हो जब आपके नंबर ऑफ एवरी पॉइंट इज डिफाइंड एज अ टू इक्विलिब्रियम स्टेट्स. ये जब तक सारे इक्विलिब्रियम स्टेट्स को कनेक्ट नहीं करोगे, you will not get a path or cross, right? That is first. Now in this properties, with respect to the properties, when I say the properties are independent of past history, इसका मतलब क्या है? You can see that this is one of the properties definition, this one is another properties of this system, right? अब ये P1 V1 से P2 V2 have many an infinite number of paths, you can see that. So ये इस बात पे डिपेंड नहीं करता है कि प्रॉपर्टीज किस पाथ को फॉलो करके अपनी न्यू डायमेंशंस एक्वायर कर रही. So that is one of the important factor कि when I say the properties is independent of past history or path it follows, right? और ये आपका प्रोसेस या पाथ तभी बनेगा जब आपका स्टेट डिफाइन हो, और स्टेट इज अ मेजरेबल कैरेक्टरिस्टिक. जो आपको P1 V1 आपने किसी एक पर्टिकुलर प्रेशर गेज लगा के आपने उसको मेजर किया होगा. इज इट क्लियर टू एवरीवन? So similarly, when I say a process, next term आपके सामने आता है state of a system. So what is a state? The condition of a system is known as the state of a system. So this is basically state, right? Or is this particular state? This is also one of the state. So उस particular point पे आपकी properties क्या है? उस particular point पे आपकी conditions क्या है? उसको define करने को हम state बोलते हैं. So the next topic that we are going to discuss is reversible and irreversible process. Reversible and irreversible process, right? You have to remember reversible and irreversible process anywhere, any like anything. You need to understand. Whenever I'm talking about the reversible process, always remember one thing: it is one of the most ideal process, right? When I say a irreversible process, it means it is defined as a real process which exists in nature, in actual day-to-day activities, right? So this is very important concept, reversible and irreversible process. Always remember. So a process, so I'm going to explain this. A process is said to be a reversible process if in reverse direction, follows the same, it in reverse direction follows the same path without having any effect on system and surround, right? So let's take one example. And we have defined this example as a quasi-static process. Quasi-static process, right? So static means stationary and quasi means almost, right? So almost a static process जो है that we are going to define. So let's see how this process works. Suppose we have a one piston cylinder arrangement. This is your piston, right? And this is having molecules of gas, and this is under pressure conditions. So above this piston, there is a sand particle is to be there, right? So the weight of the sand uh, exert downward forces, and with respect to that, the position of the piston is defined. Okay. अब हम क्या कर रहे हैं? Every particle of the sand I am removing from this point, right? अभी क्या होगा कि जैसे जैसे ये sands remove करते जाएंगे, over the time you will find when there is no sand, this piston should move at this particular, right? So I believe you also understood the removing of single sand till this point to the last particle of the sand takes infinite time, right? So this process is almost very slow. So this is one of the position of the piston, and this one is the second position of the piston when there is no sand there. Now, अब यहाँ पे आप चीजों को समझने की कोशिश करो. This is the wall of the piston, right? This one. अब जब ये piston upward direction में move करेगा, so if this is a frictionless, तो ये क्या होगा कि यहाँ पे कोई भी फ्रिक्शन जनरेट नहीं होगा. सो जो कोई भी फ्रिक्शन जनरेट नहीं होगा, तो बिकॉज ऑफ दिस मूवमेंट दिस पिस्टन इज डूइंग वर्क. दिस इज योर सिस्टम एंड दिस वन इज योर सराउंडिंग, राइट? तो पिस्टन सराउंडिंग पे वर्क एक्सर्ट कर रहा है, ठीक है? तो आपने सपोज किया कि सपोज डेल्टा डब्ल्यू अमाउंट ऑफ वर्क इज फीलिंग surrounding. Similarly, the same amount of work is done by the system. So based on that, this is of the minus value and this is of the plus values. तो अभी भी अगर आपने सिस्टम और सराउंडिंग के बीच के एनर्जीज कंटेंट देखा, that should remain same. If I say system plus surrounding, so again the summation of this energies remain constant. Again, अब आप इमेजिन करो कि यहाँ पे आपने इसी पर्टिकुलर पॉइंट पे अब आप इसको जो है सैंड पार्टिकल जो है उसमें ऐड करते जा रहे हैं. जब आपने सैंड पार्टिकल्स ऐड किया तो अगेन ये टू पोजीशन ऑफ जो आपकी पिस्टन की थी, इट विल कम बैक टू इट्स इनिशियल पोजीशन दैट इज डिफाइंड एज 1. सो हियर इन दिस केस वी कैन से दैट दिस प्रोसेस 1 to 2 and 2 to 1, we can say that the process 1 to 2 and process 2 to 1 is a reversible process, because first it follows the same path, as well as it does not have any effect on system and surrounding, right? On the other hand, you see conditions. अब आप इमेजिन करो कि यहाँ पे अब आपका एक फ्रिक्शन पार्ट रोल प्ले कर रहा है, राइट? व्हेन दिस पिस्टन मूव्स, क्या होगा? ये फ्रिक्शन की वजह से यहाँ पे हीट जनरेट होगा। तो जब ये हीट जनरेट होगा तो ये हीट लिबरेट होगा किसमें? सराउंडिंग में, राइट? अब फ्रॉम दिस प्रोसेस टू दिस प्रोसेस आपका फ्रिक्शन जनरेट हुआ, सराउंडिंग में आ गया। क्लियर? तो सपोज अगर आपने इस सिस्टम को Q अमाउंट ऑफ हीट दिया था 100 किलो जूल, so that same amount of heat is also to be transferred to the surrounding, but अब आपका 100 किलो जूल हीट के बजाय ये 10 किलो जूल ऑफ हीट एक्स्ट्रा जनरेट कर रहा है बिकॉज ऑफ फ्रिक्शन। तो अभी आपने क्या देखा कि 100 किलो जूल जो इफेक्ट आ रहा था वो अब 110 किलो जूल आ रहा है। नाउ देयर इज अ डिफरेंस ऑफ एनर्जी बिटवीन सिस्टम एंड सराउंडिंग, राइट? दो इट फॉलो आपने पहले इसको रिमूव किया, फिर आपने उसमें ऐड किया। अब आप क्या देख रहे हो कि दो इट फॉलो द सेम पाथ। आपने देखा कि 1 से 2 और 2 to 1 फॉलोज द सेम पाथ, but energy interaction between system and surrounding is changed. So we cannot say that this is comes under irreversible condition, and this process is defined as reversible. So friction is always, remember, friction is always play a very crucial role to define reversible and irreversible process. So I just repeat one in this slide. The first, what is reversible and irreversible process? A process is said to be a reversible process if in reverse direction follow the same path without having any effect on system and surrounding, right? A reversible process is the most efficient process. A process which is not reversible process is an irreversible process. And with respect to the statement of quasi-static process, a process is carried out in a slow manner is known as a quasi-static process. And the important point is frictionless quasi-static process is defined as a reversible process, right? Now, the last topic is defined as a thermodynamic cycle. Thermodynamic cycle. Thermodynamic cycle, right? So what is the cycle? Let us first understand what is the cycle. A system is said to have undergone a cycle if the initial and final points are same. It means what? If I draw in a coordinate system, suppose this is one of the point, this is another point, this is point 1, this is point 2. So if I say it is a process, then process is carried out between 1 to 2, right? Likewise, if I say that process is carried out between 2 to 1. But the combination, you can say that the process starts from 1, ends at 2, and again starts at 2 and ends at 1. So this is a complete cycle because the initial point and the final points are same. So with respect to the statement, you can say that a system is said to have undergone a cycle if the initial and final points are same. That is one basic statement about thermodynamic cycle. If I ask what is the change of properties in a cycle, if I ask what is the change of a property in a cycle, you can see that at this particular time point, जब भी हम प्रॉपर्टीज की बात कर रहे हैं तो आपको ये समझना है कि प्रॉपर्टीज का क्या मतलब होगा। प्रॉपर्टीज का मतलब होगा, शायद हम आपसे ये जानने की कोशिश कर रहे हैं कि इसका टेम्परेचर की बात हो रही होगी, वॉल्यूम की बात हो रही होगी या प्रेशर्स की बात हो रही होगी, राइट? तो सपोज अगर ये टेम्परेचर कोऑर्डिनेट्स है, so this process will start at this particular point. तो ये वन पॉइंट एक T1 टेम्परेचर को शो कर रहा है ना यहाँ पे। अब ये इट इज मूव फ्रॉम वन टू अनदर पॉइंट, देन टू टू वन पॉइंट पे। अब आफ्टर इनिशियल पॉइंट पे इसका टेम्परेचर T1 था, when it reaches to the same point again the temperature is to be remain T1 ही है ना। तो if I ask you भाई what is the temperature change, तो आप क्या लिखोगे? T1 minus T1, it should be 0, right? So for a cycle, it is always remember, for a cycle a change, for a cycle a change in property, for a cycle a change in property is equal to 0, right?